All right, let's move on to the second section, fractions. Let's check the first objective. Fraction properties with 0 and 1. But before we start this topic, let's just review this property of fraction. We know the fraction bar is just same as the division sign. So we can write 8 over 4 equals 8 divided by 4 equal to 2. So similarly, if we have 9 over 3, we can treat it as 9 divided by 3 is equal to 3. So this is just a quick review of this property. Now let's check the properties with 0 and 1. Okay, first, let's define A is a number not equal to 0. Then we can have these properties. A over A is equal to 1. And 0 over A is equal to 0. A over 1 is A. And A over 0 is undefined. Okay, let's check some example to help you understand the properties. Okay, but these are the properties. So let's check several examples. So let's check the first property. A over A is equal to 1. So we will say A is a non-zero number. So it's 4 over 4 equals 1. Right? And 9 over 9 is 1. Okay? So this is about A over A equals 1. So A over A equals 1. Let's check another example. 0 over a non-zero number. 0 over 9 equals 0. Of course, 0 over 3 is equal to 0. So 0 over A equal to 0. So about a number 9 over 1 is still equals 9. And 6 over 1 is still 6. Then that's the proper property. A over 1 is equal to A. Okay. And the last one is any number over 0 is undefined. Okay. Now let's move on to objective B. We should write the equivalent fraction. Fraction. So let's check the example 7 in the book. We write one fraction 2 over 5 as an equivalent fraction with a denominator of 15. So we want to write 2 as an equivalent fraction, but this fraction with the denominator of 15. So we just need to know what's the numerator part. So we can try to do it like this way. because we want to change 5 to 15. So we know 5 only need to times 3 can be 15, right? So we should do the same action to the numerator. So we also need to times 3. Then we can get this is 6 over 15. We can try another one. This time we want to write 1 over 4 as an equivalent fraction with a denominator of 20. So this time we know how can we get 20? We only need to use 4 times 5. Then we can get 20, right? But we do the same action as the numerator. So also need to times 5. So 1 times 5, we will get 5. So 5 over 20 is our answer. Okay, so 1 over 4 is equal to 5 over 20. These two fractions are equivalent. Objective C is try to simplify. Okay, let's check example 8. If we want to simplify 42 over 49. So we should write our fraction like this. 42, we can write it as 6 times 7. Then we can check 49 denominator. We can write it as 7 times 7. Now we realize we can cross out the times 7 for both numerator and the denominator. Then we can easily get 6 over 7. Okay, let's try to do another one. Try to simplify this one. 20 over 35. So we still need to factoring the numerator first. 20, we can write it as 4 times 5. Now we check the denominator 35. We want to write it as 5 times 7. Then we both have 5 in our numerator and the denominator. We can cross out. Then we have our number 4 over 7. Okay? Now let's check objective D. We will do the multiplication and the division for the fraction. Multiplication, multiplying, and dividing a fraction. So for any multiplication, we follow this rule. A over B times C over D, we will get A times C over B times D. But we should know B times D cannot equals 0. Of course, this is fraction, this is denominator fraction, so both b and d cannot be 0. So let's check an example. Example 11 in your book. Let's try to multiply two fractions. 2 over 5, 2 over 15 times 5 over 13. So let's check this one. Will be a over b times c over d. Then it will be a times c. That will be 2 times 5. The numerator times the numerator. Denominator times the denominator. But if we want to get our answer the simplest form, so we can do the simplify here. So we can write 2 times 5. That's fine. But 15, we can write it like 5 times 3 times 13. Okay, then we realize both numerator and denominator have 5, so we cross out 5. Then we will get 2 over 39 is our final answer. And 2 over 39 is already the simplest form of the fraction. Okay, let's try another one. This time we do another multiplication. So 3 over 4 times 8 over 9. Okay, 8 over 9. We do the same thing. The numerator times numerator. 3 times 8. Over denominator times denominator. But we can rewrite our fraction here, 8. We write it as 4 times 2. And 4 times, here 9, we will write it as 3 times 3. Then we can cross 3, both numerator and denominator, and cross 4, both numerator and denominator. And we will have our answer is 2 over 3. That will be the simplest form of our fraction. Okay, that's for the multiplication of fraction. Let's check the division. Division, if we want to do the a over b divided by c over d, we will transfer our division into the multiplication. It will be a over b times d over c. Okay, of course, here b times c times d not equal to 0. So any one b, c, d cannot be 0, right? So let's check the example. Here we want to do 4 over 5 divided by 5 over 16. So we switch our division into the multiplication. We just try to change the order of the denominator and the numerator. So it will be times the reciprocal of 5 over 16. That will be 16 over 5. Now we only need to do the multiplication. Then the numerator times the numerator. 4 times 16. Denominator 5 times 5. So that will be 64 over 25. Okay, that's for the example in your book. And we can check another one. So this time we want to do 7 over 10 divided by 14. So we know we can just follow the same rule, but this time you can treat 14 to be a fraction, like 14 over 1. Then you just do the same thing. Switch your division into a multiplication. So divided by 14 over 1 is just the same thing as times 1 over 14. Then we can do the multiplication. Then numerator times numerator, denominator times denominator. And we can write times 14 like 7 times 2. Then we can easily cancel out the fraction to get the simplest form of the fraction. Okay, that's for the objective D, multiplications and the divisions.